All right, so we have a team of soccer players that have the weights, they're listed there, and we want to list all samples of size 2, and then we're going to find the sampling distribution of the mean. All right, so we've got these 5 weights here. Let's list all possible samples of size 2. So we could have the 160 person with the 162 person. That's one sample. We could have 160 with 170. We could have 160 with 155. We could have 160 with 142. All right, that's every sample of size 2 that has 160 in it. So let's do 162 with 170. And I could have 162 with 155 and 162 with 142. That's everything with 162 in it. Now we go to 170 with 155 and 170 with 142. And finally, the last sample of size 2 is 155 with 142. And that's all samples of size 2. So now we've got our list of all the samples of size 2. Let's find the sampling distribution of the mean. All right, so we're going to find the means for all of these. So the mean, adding 160 plus 162 and dividing by 2, this gives us 161. This one, adding 160 and 170 and dividing by 2, we get 165. This one, 160 and 155, add them together and divide by 2, we get 157.5. This one, 160 and 142, add them together, divide by 2. That gives us 151. 162 plus 170 and divide it by 2. That gives us 166. 162 and 155. And divided by 2, we get 158.5. 162 and 142, and then divide by 2, we get 152. 170 and 155. That averages to 162.5. 170 and 142 averages to 156. And finally, 155 and 142. 148.5. All right, so now we list out here the probability of each one. Now, we're assuming that when we randomly selected samples of size 2, they were all equally likely to be chosen. So the probability here, there are 10 different means, and let's notice they are all different. So the probability is 1 in 10 of getting this mean, and 1 in 10 of getting this one, and so on. Now, if one of them occurred more than once, let's say it occurred twice, we'd have 2 in 10 for that particular mean. But of course, they're all distinctly different in this instance. So their probabilities are all 1 in 10. All right, now, something that we want to note here. If we went ahead and averaged all of these means together, so if we took the mean of the mean, which is our new symbol for the sampling distribution of the mean, so we're taking the mean of all of these means, so we're averaging them all up. So in other words, if I add together this entire column, that is 1578. And if I divide by the number of means that I have, 10, that gives us 157.8 as the mean of the sampling distribution. So the mean of the means. Now, let's notice something though. here was our original population. Let's just find the mean of that population. So in other words, let's just add up 160, 162, 170, 155, and 142 and divide by 5. So I'll add those up. That's 789. And if we divide that by the 5 pieces of data in our population, we get 157.8. So notice the mean of the means, the mean of the sampling distribution, is the same thing as the population mean. And most times we don't know what the population mean is. This is a very small population, but this will always be true.